That's all, no? So finish or there's no need to discuss anything. No, actually, where the pressure will be more. Okay, let's do one thing. Let's go for pressure. So here, this is outside pressure will be P naught, no? So what is the pressure in the P1? Pressure in the bubble. Okay, let's do one thing. Take radius R1, R2. It'll be easy for us. Yeah. What is the pressure in the bubble? Bigger bubble? Big, no. Okay. Big, small, it should be. Yeah? No, P1 should be equal to P naught plus 4 ST by R1. What is P2? P2 should be P naught plus 4 ST by R2. Tell me like which R2 less than R1? As R2 less than R1. So P2 will be P2 will be greater than P1. Will I agree this? P2 will be greater. Pressure inside the smaller bubble will be more than the bigger bubble. So when the smaller bubble comes in contact, or when they come in contact, so as the pressure here more than this one, so definitely what happens, the surface will be pressed more into the larger bubble than the bigger bubble. So therefore, how we have to show the free surface now? So here it will be let me so this was the green color now. Try to see carefully. So this will be the I think I can erase. Huh? Yeah. Okay, just give some time. Huh? They're not responding properly. Yeah. Same size. Okay, this is what happens here. Huh? Okay, now I'm interested in the common surface area. Oh, eraser not responding. Huh? Yeah, luckily. Okay, got it. Now the common surface area I'll show by red color. You try to see this. Now if I draw the radius of this, it'll come like this. Huh? He's asking radius of this common surface, and the radius of this bubble is how much? R2. R1, R2. Which radius will be more? The radius of the interface, no, the common surface. The common surface, I'll call it as AB. If you want, you can show that common surface stick. So what is AB? AB is common surface. Okay, there's a basic picture of this one. So what is the pressure here? Will be P1. Pressure here, how much will be? P1, pressure here, P2. Okay, let's get into the concept here. Where according to the concept, where pressure should be more on the concave or convex side? Pressure should be more on the concave side, no? So P2 should be greater than P1. By what factor? 4 ST by R. What is smaller? Radius of curvature of this one. See, actually, don't think that there is another red color bubble. I just shown this dotted line to tell you that the radius of curvature of the common surface will be other than this radius of curvature of the smaller bubble. Are you able to understand, all of you? This is the common surface. This is a common surface. I should not, it's not a liquid drop, it is not a liquid drop, it's a bubble only. Actually, two surfaces should be there, will get confused. That's why I'm just showing only one surface for the bubble. Everyone able to understand? Okay, now what is P2? P2 already we know. 4st by R2. P1, 4st by R1. 4st by R. So finally what we are getting? 1 by R2 minus 1 by R1 equal to R. So this will be R1 R2 by R1 minus R2. There's a radius of curvature of the common surface. AB is a common surface. Please do notice. So when a smaller bubble comes and sits on a bigger bubble, so what will happen? The surface, the common surface will be pressed more into the larger bubble than this one. Agree this? So this is our answer. Okay, let's go into further. Few many things are there after this. Okay, now. Okay, let's take the same diagram. Please do make. I'm so many questions can be asked here again. Let me. Okay, this what we discussed. No. Pressure P1. This is what bigger bubble. This is the smaller bubble. Pressure is P2. This is a radius R. I'll just take it out this. This is not needed for us. Let's talk about the angles here. What is AB? AB the common surface. Will I agree this? Same discussion, I just brought it. So here, let me bring now. What is O1? What is O2? O1 is center of the bigger bubble. O2 is that of the smaller bubble. Will I agree this? What about this equilibrium angle? So here I'll bring the arrows. Are you looking the arrows? I should draw a tangent, no? These arrows. So these are the angles. Let me bring it here. Alpha, beta, alpha, beta, gamma. Anything can you say about these angles? So what is this? Why you are asking all such things? It's needed, no? What is these arrows? First of all, what are the arrows? Force due to surface tension. Here open the liquid, the molecules which are there, they'll exert force. The molecules which are here, they'll exert force. And at interface also, they'll exert a force. So here altogether we get it. Now, what is the surface tension of all this? It's same, no? What is the surface tension of the smaller bubble? The same liquid is taken, the same soap solution. Try to see that one. What is the surface tension of this layer of bubble? The same surface tension. What do you get? Means like I'll take water. Then I'll add aerial powder for this. Then I'll add Arial powder. Then I'll make two bubbles. Then what do we get this interface? So what happen? The property of that also will be same as that of these bubbles only. This layer, all three layers are having same surface tension. Are you getting no? Surface tension of this soap solution and this soap solution, soap bubble are same. So the common surface which is formed, it will also have same surface tension. So therefore now, what do you expect the force? The force also will be same. So definitely these forces, if you look at the magnitude, no, they'll be equal. I should not show F for your convenience. I'm showing that one. And the surface tension is same. So definitely what happened to alpha? Alpha, beta, gamma equal to 120 degrees. If the surface tension of this film and this film are different, then anyway, equilibrium has to reach. The angles will be different, but the net force of this particular point for equilibrium, it should be zero only. But angles can be different here. So since we are, if the two bubbles have come now, we are discussing this idea. They're made up of same soap solution. So therefore, definitely alpha, beta, gamma equal to 120 degrees. Getting this condition now. Okay, we'll take the next idea now. Okay, if the two soap bubbles, if two soap bubbles, if they come in contact of same radii, if they come in contact, what will happen to the common surface? How it will be? Anybody? Let's take you to this one. If R1 equal to R2, tell me what happened to R? Anybody wants to answer? If two soap bubbles of same radii, if they come in contact, what will happen to the radii of the common surface? If R1 equal to R2, then R will become infinity. No, infinity means how the common surface should be straight line. Yes, if the two soap bubbles, let's take a discussion here. So there's a one. So both are